Welcome all. Thank you for joining us today. Kind of like this environment, a little more intimate and feels very googly in a sense. So my name is JD. I'm a product manager with Stackdriver. And I'm here today with Shoukong Chen, who's going to join us later. He's a technical lead for our Kubernetes monitoring experience. And so we're going to tell you a little bit today about how do we do Kubernetes monitoring, a little bit in the way that Google does. Some of you, let me just check here. Who was yesterday in the talk, the hybrid monitoring and logging session? A few people? OK. So you'll see very much the same demo in a sense and a few more other things that we're going to show you as well. So let's get started. So we had that introduction. Well, as I said, we're going to try to go through a couple of scenarios, how we monitor and troubleshoot Kubernetes in production. We'll talk about some of the best practices that we do and a little bit about observability and so forth. We do assume some basic knowledge on Kubernetes, of course, as we're doing some things here in that end. So first thing is, let's talk about observability, reliability, and software velocity. Just a quick show of hands. Who here is a developer? All right, almost everybody. Anybody in operations?
Okay.
A few as well. And who does like truly DevOps? Okay, so great. So let's thinking from all of you developers and many of you who may be our partners, our customers, and so on, you know that software velocity now becomes a real necessity. It's a competitive advantage. For you to be able to innovate in your market, to compete for business, compete for some customers, and so on, you really want to be able to accelerate the pace of your software velocity, of your innovation, and so on. Now, the difficult thing, however, is to do that while at the same time maintaining reliability. Right? You're able to do one or the other very well. Now, one of the key things that Google has done that it's very good at is for the almost 2 decades now, we've been able to have a great pace of innovation while still maintaining software reliability and also minimizing security exposure. So there's something that Google has done at massive scale of being able to do both of these things. And so what we're trying to do now on our team and on the SRE group and so on is to externalize many of these SRE practices so that our customers and our developers and so on can do the same things in the way that Google does. Now, when I say monitoring or developing the way that Google does, sometimes I get high eyebrows to say, well, we don't have the scale that Google does. We don't need to do exactly the same things. Now, our point is that, yes, regardless of scale, you do want to take advantage of some of these best practices because you do face the same type of issues. The way you want to deploy applications, the way you want to monitor at them and so on, are the same type of problems, just the scale might be different. So let's talk a little bit about that in general. So Kubernetes is an example of how we've been doing this, right? The way that Google does things today, everything pretty much runs in a container. We have an internal system we call Borg. Well, everything is isolated very much in a container state. So as you see here, we really, on average, on a week, we launch more than 4 billion containers. So we've certainly amassed some experience in how to deploy and then manage this type of container-based applications. And so what we're trying to do now with our processes and our tools is to externalize those best practices precisely. And we've been doing this in multiple ways. The first one is our infrastructure. So internally, aside from, of course, our opinionated infrastructure we call Google 3, it's done in a way where developers from the very beginning, they can really focus on writing code. A lot of the instrumentation is ready, happens sort of automatically. We know the type of things that infrastructure is expecting, so we can do some things automatically, right? Now, of course, we cannot just put Google 3 out. But we've done some of these things via some of the externalizations, like Kubernetes precisely, right? Kubernetes is, in some ways, an externalization of our Borg infrastructure and practices. Now, you saw yesterday on the keynote our Google Cloud Service Platform announcement with Istio and so on. So we've done the similar thing to manage services across and coordination. So Istio is an example. For instrumentation, we use something called sensors. And Google has invested now in externalizing that via open sensors. So the intent here is to give you a way in which you can instrument your application one way or one time And then you can choose multiple backends and switch over. You may want to use Google's Stackdriver as a backend. You may want to use a different backend to do your monitoring and your operations. And that's fine, because you don't need to go back and change your instrumentation. And that's the way we do it internally, and that's what we're doing now outside. And the same thing in terms of our procedure calls. We now have gRPC as an externalization. So that's infrastructure and people in some sense, right? The processes that we do. Now, best practices. I'm using the collective we. I had nothing to do with that book, but we at Google SRE, well, we wrote the book on operations, literally. Site reliability engineering, and who here has visited the Fifth Nine on Moscow West? If you haven't, please just a couple of hands. Stop by. It's a booth with all of our SRE team, and you get ideas. You can actually get a free copy of the book and signed up and everything else. So I invite you to do that. So we've amassed all these practices. We're now externalizing them in terms of books, white papers, training and certification, and so on. When I looked at LinkedIn just very recently, on my profile at least, I saw roughly about 26,000 people with roles now that have SRE in the title. So we're certainly now making a mess in terms of changing a little bit of the culture and what involves in these type of practices. And then finally is our tools, of course. If we don't have the right tools that are trying to implement the same type of workflows that comes from both best practices and those processes, then you have a mismatch. And so now Stackdriver is an example of that tool. It started initially as an acquisition we did 4.5 years ago or so, but that was just the beginning. That was focusing on just a small piece of it, which was monitoring. And we've expanded that into a full product suite that now has multiple components. So let me tell you a little bit about Stackdriver now. It's a fully managed product we have on cloud. And the main mission that we have on our team is to help developers and operators keep your applications running fast and always available. And a key thing here with Stackdriver is that it was built from the ground up to help you do your apps and monitor your apps no matter where they run. They may be running on Google Cloud. They may be running on AWS. They may be running on cloud-native infrastructure, as we'll show today with Kubernetes. And now with the Kubernetes monitoring, then we also have the possibility to monitor on-prem as well. Now, all of this is built on a massive platform that we have at Google in our backends and our stores and so on. And the key thing here is that what we're doing is we're amassing a lot of signals throughout the full stack, starting from our cloud services, from Google Cloud, from AWS, to operating system and third-party application components. Let's say in your app you're using, let's say Nginx, Redis, Kafka, anything that's out there as a third-party application components, all the way to your main application, your business, what is meant to do. So all those signals, we get all of those together. It's not just about monitoring. It's not just about metrics. It's actually logs, metrics, events, snapshots from debugs, traces, and we get all those signals together into our backends. Our backends are stores. And we have this part that I mentioned as a massive platform. To give you an idea, we monitor in this time series database that we have internally, we monitor more than 3 billion resources. Roughly about 480 terabytes in RAM, because it's a highly distributed in-memory time series database. On our logging backend, we have on a day roughly 35 petabytes a day. So it's a massive infrastructure that we have that we're now putting outside for all of you to use and take advantage of that. Stackdriver is built on top of that infrastructure. And so what we do is we use that, and then we create a set of tools that we have exposed to all of our customers, so you can do visualizations, use them in dashboards, create multi-condition alerts, have notification channels to many different ways. And to do that, we actually rely on many of our partners. So what we're doing is we actually are building all this, because we know we cannot be everything to everybody, right? There's things that we cannot do. It's not a core focus. And so many of our partners come in and fill that gap. And most importantly, many of those partners come in and fill, help us build that ecosystem and create it much better. Build value on top of these platforms. So we have a few of our partners here today. Many of you'll see here. And I'm actually excited to talk specifically about one partner, xMatters. We just announced a partnership with them, and they're helping us build a set of notification channels and integrations so that it helps customers when they're using Stackdriver. If you get a notification when there's a particular incident, there was a failure, Now, using X Matters, our customers will have ability to then integrate with many other services, including dozens and perhaps hundreds of integrations in that sense. So it really helps customers get to the core of an issue and resolve things faster and so forth. So let's go now briefly into our monitoring offering today, the Kubernetes monitoring solution. And you know, the building modern apps, it's quite different from what it used to be in the past. Today, many of you raised your hand saying you're a developer. And you know, I wish most of you want to just focus on building code. Am I right? Yes, if you could. We can't anymore, right? Like, there's so many things that we have to do. We want to choose our infrastructure. We want to do setups. Then we're going to do a containerization, work with a specific orchestration system, most likely Kubernetes, choose storage, instrument our applications to do then monitoring, set up our monitoring and observability tools, and so on. So getting observability, and by the way, I'm using the term observability here, and I know it sort of became kind of like a buzzword recently. But at Google, we truly mean, and from many years ago, we've been talking more about observability. It's not just monitoring. Monitoring is one piece of things. Monitoring is just that activity of going in and looking at specific things to prevent failure. Observability is more a property of a system. So from the beginning, what we're trying to do is to get our systems being designed with reliability in mind. It really is an engineering practice. And so we're trying to increase the signals. That's why you see metrics, logs, traces all together, because we're trying to increase the observability of our systems so that we can know how they operate under normal circumstances, and also how they operate when there's failure. So that when we can quickly resolve issues, speed root cause analysis, and help us resolve the issue and then learn back on. Kubernetes actually makes things a little bit trickier because on the one hand, it gives us so much flexibility, it's great. We start with new microservices, so it really allows us to break this monolith into multiple microservices, but that means that we have more pieces to monitor and operate. The second thing is that we, of course, have abstracted infrastructure. You have so much flexibility. You can use different types of controllers and deployments and stateful sets and all these different components. And then again, when you're using those, now you have to infer the state of those components when something goes wrong. So you really want to be able to have pretty well spread out observability throughout your entire Kubernetes environment. And finally, Kubernetes is really a highly dynamic environment. If you're using auto-scaling and of course, the scheduling and restarting and so on, that's a natural occurrence in Kubernetes. So you want to be able to have a system that allows you to always know the state of where things are, no matter where they are. And of course, you're not really looking at your applications necessarily like knowing in which machine they are, right? That's the idea. We want you to not think about any of those things. And so, but that means now that you need to keep track of where your application is and what it's doing and so on. So what we have right now is a new solution, which is Stackdriver Kubernetes Monitoring, and we announced recently it's in beta, and we've been expanding it rapidly. So we invite you, all of you, to please start using it. If you haven't already, give us feedback. The feedback that you give us right now, like we directly are reading those messages. So we want to build a product that is most useful to you. There's many things that are not available yet in Stackdriver Kubernetes Monitoring. We want to get those things out to you as fast as possible. So let me go through it very rapidly. Some of the things that we have. First, it's comprehensive observability. What do I mean by that? Out of the box, without you having to do anything, you get all this instrumentation done for free, so to speak. You get instrumentation on all your Kubernetes objects, and you get not just metrics. You get metrics, logs, and we have traces as well. And there's events and metadata and so on. So really trying to increase that. It works very well with open source. From the ground up, we built it and integrated with Prometheus, which is, of course, the most well-known monitoring open source solution for Kubernetes. It's multi-cluster monitoring, which is a difference that you see for many other products outside. In a single place, we're giving you a way to do multiple monitoring of multiple clusters. And it doesn't matter where it runs. We can monitor your cluster on-prem or your cluster on Kubernetes Engine, or your cluster running on AWS EC2 instances, for instance. One last thing that I would say in this respect is the fact that you have the observability no matter what your role is. So it goes back to that idea of this platform that we created. This platform for us created a single source of truth. Many of you are using multiple tools, very likely, and what we do is we have just that single platform where all these signals come together. So you don't have to stitch and cobble together multiple tools to try to create that source of truth. So if you're a DevOps or an SRE, you may want to look primarily at your infrastructure. If you're a developer, you may look at your application and your workloads and so on, which we'll show in the demo. And if you're a security engineer, you may actually be looking at your logs and audit trail and so on. That is actually also part of Stackdriver. So I mentioned before, it works very well with open source, with Prometheus. One of the main maintainers of Prometheus, Fabian Reiners, joined Google, our team, just a couple of months ago. So we're directly working with him to make sure that we continue to contribute to Prometheus, to expand and contribute to this vibrant community, and ultimately to make it very easy to switch and make sure that Prometheus integrations can move into cloud when it's appropriate and when wanted and needed. So this is what we'll be seeing today, a hybrid multi-cluster approach for Kubernetes monitoring. And I think the best way to do that is through our demo. But one last thing I'll say is that this offering works very well, self-contained, like you get your Kubernetes observability. But it works even better when you use it with the rest of the Stackdriver tools. And hopefully at the end, we'll show you a little bit of this. The idea, again, by using all those tools and signals together is that we try to give you a means to speed your root cause analysis. You'll see in a couple of the demos here that we're trying to focus your attention into the information that matters the most to you so that you follow the trail that we believe is the one most likely to give you the root cause for things. So with that, I'll turn to Shoukong, who's going to tell us a little bit about the internal architecture.
Okay, thanks, JD. So this is Shoukong. I'm the tech lead of Stackdriver Kubernetes Monitoring. Could we switch back to slides for 1 second? And
switch back to slides, please.
Could we switch back to slides for 1 second? Yeah, so I'm going to give you a very brief overview about what our Stackdriver Kubernetes monitoring architecture is. So as you can see, so there's a kubelet running in your cluster. So there we have some of the Kubernetes metrics, very important one, like the CPU usage, restart count, and whatever is there, are collected by the hipster. And we offer Stackdriver, we have a monitoring API, which is public on the internet. So hipster sending this metric into our monitoring API. That is how we collect system metric for your Kubernetes application. In the same time, we have the Stackdriver Prometheus collector, which is a sidecar running in your pod. And it collects, scrape all the Prometheus metrics that's available there per your config, and then also write into our monitoring API. So this is the path for how metrics flow into Stackdriver. And in the same time, we have the two daemon sets. One is the Stackdriver metadata agent. It collects all the metadata like your Kubernetes label, your hierarchy in your Kubernetes, and what all the config you have specified, and then sending it to the resource metadata API. And the logging agent is also another daemon set. It collects all your standard out, standard error, all the logs you care about, and then sending it to our logging API, which is backend is our logging storage. This is the architecture of this offering. So we want to explore a little bit more about how Prometheus metrics integrates happens. So as you can see here, so on the top is the gray chart, is like how you do Prometheus metrics in open source. So there's a official Prometheus collector scraping the Prometheus pods and then sending the data and graphing in Grafana. On Stackdriver, we have another Prometheus collector, which collects data and then sending it to Stackdriver backend, which is Cloud Monarch, which is our Google Planet-scale time series database, which JD has mentioned before. It supports all of our Google workloads, including all of the Google Cloud platform. It's a time series database for that. And we have the Stackdriver monitoring UI, which is graph the time series data from Monarch. You can also use our Grafana integration, use Grafana to read from the Monarch to graph whatever dashboard you want. So this is the brief introduction about our architecture. Now let's go to the demo time. One more slide. I will explain. So this is a very classical demo that probably some of you have already seen. It's a pet clinic from Spring Communication. So how many of you have pets? Like, if you raise the hand, oh, come on, you have, oh, okay. We have plenty of people have pets. So as you can see, today we are going to use this pet clinic demo this is going to give you a list of owners, and then some of the pet visits, pet information, and then some of the doctor for your pets. So let me very briefly describe how this application is set up. So as you can see, we say this is today's demo is a hybrid demo. So that's why we set up a GKE cluster and an on-prem cluster. They are both running the same app. As you can see, there's an API gateway, which is routing all your traffic into different backends. There's a customer service, which gives you the detail of owners, and a visit service, which tell you what's your visit to the pet clinic, and some doctor service. All of these connecting to a remote cloud spanner storage with all of your data. So this is the setup. Okay, so I'm heading back to JD, but we will run a demo for this proactive monitoring. Oh. Can we switch to demo?
This? Thanks, Shoukong. All right, so let's try to show you a little bit of this application so we get a sense for it and orient ourselves. So as Shoukong was saying, it's just an app, very simple one, allows you to get information as an owner of a veterinary clinic. I just track who are my customers, what pets they have, what visits they've done to the veterinary clinic, and so on. So let's show the list of owners, Shoukong, right now, to get a sense for those. The app, you may see it's a little bit flaky on purpose to try to show some issues with latency and other things. So what we're going to do here is add a new pet to a pet owner, and we can do, I guess, the same one, add the date of birth, and then the type. Maybe you want to introduce a bug with the cat just in case we want to use it later. If we do add another pet, and that's a very apropos name. So we introduce a little thing here so we get error requests and so forth, just in case they may be useful for us to demonstrate other things later on, if we have time. All right, and now we could do other things. We could do add visits for the pets if we want to have more data and traffic into this application. But what we want to do now is to actually create some actual traffic for it. We would be asking you, as we did in the demo yesterday, we're asking you to do this in particular, but let's do it now today. We have one command. What Shoukong is doing right now is we're going to our on-prem cluster, and now we're actually scaling that cluster to make sure it simulates some traffic. Let's do the same now on the GKE side. We run the same exact command. We're just going to scale up our load generator, and then essentially creating that particular traffic here for Kubernetes. Now, Shoukong mentioned you have many ways of doing monitoring. You could have done Prometheus and Grafana, most likely if you're using open source. What we're going to do today is just focus on the Kubernetes monitoring experience. So we're going to do just that. Why don't we try to go now into Kubernetes monitoring, which we do by going into our Cloud Console. We choose the monitoring piece from the Stackdriver section. That gets you into the Stackdriver console. This is the Stackdriver monitoring piece. Remember, Stackdriver is actually a full suite with many components right now, 6 different components. So we're in the monitoring console now, and by going to resources and Kubernetes, we'll get to the Kubernetes monitoring offer. And so you see here essentially that Kubernetes monitoring console right now. And just let me try to orient ourselves here a little bit on this console. On the upper side, you see that widget is the event timeline. It's our event widget. What we're trying to do here is surface Kubernetes events that may be relevant to you. And this is actually a heat map. So you see the more transparent colors, the more solid colors actually have higher frequency of events. The less solid ones are less events and so on. Now you can modify time sets and other things. But the important thing here is that we want to surface events that you can then correlate with the state of your Kubernetes environment. Today in beta, we're just surfacing events related to incidents. Now, incidents are essentially violations of your alerting policies. So you created alerting policies by defining, let's say, conditions that you believe are your own notion of health, right? Something you would say, this is when this happens, most likely a failure or a situation that we want to avoid perhaps is likely to occur. So we want to use those. When a failure occurs, we create an incident, and those are the ones you're seeing here. Now, let's focus our attention on the pane below. This is our multi-cluster monitoring, and as you can see here, there's already 2 clusters, the ones we have. Out of the box, you actually get those clusters together in a single place. Now, for the GKE cluster, there's nothing you need to do. Right? No action is needed. You get pre-integration with Kubernetes Engine. All the data gets in, and there's nothing to do. For the on-prem cluster, the only thing you need to do is deploy the Stackdriver agents. So the agents that Shoukong showed us earlier, a metadata agent and a logging agent and so on, we deploy those with a very simple set of instructions. Now, in this pane down below, we also try to surface information that is key to give you a sense of the health of your cluster. So we have pod readiness, we have incidents that may have occurred in any of the objects, and we have some key consumption utilization for resources and so on, like CPU and memory, relative to requests and limits that you may have created on these objects. All right. The other thing that I want to show you is the fact that, and I mentioned this before in one of the slides, no matter the role you have, you can choose a different view on this part. So if you're an operator or SRE, then you may want to actually look in your infrastructure and take a look at your nodes and the health of your nodes and how performant they are and so on. So we can do that. If you're a developer, then you may actually want to look at your deployments or your services of your application, right? And so Shoukong showed us a few more earlier. And there we go. We have one of our the default namespace that he's going in. And notice right away that there's something here. And this is what I meant earlier. Now, because we scaled up, and Shoukong is going to show us that in a minute, something is going on. You immediately see that there's something, we're focusing your attention on the pieces of Kubernetes that you may want to look at right now. And Shoukong will demonstrate that in a little bit more detail in a minute. So you can go now into the details of many of these Kubernetes objects simply by inspecting them on demand. So here we just clicked on a pod, and you can see that it's still ready, it's running. It actually has an incident open, that pod specifically, so you know there's something particular on that pod. And then I can go in detail through the rest of the key metrics, memory, storage, networking, and so forth. And in the same place, we also include logs and metadata for you, right? So now it's really logs that are only relevant for that pod, for that particular period of time, events and metadata that are only relevant for that particular period of time in those components. And that's what I meant earlier by trying to increase the observability of your Kubernetes environment. Not just having you to look for those things in separate tools altogether, but rather bringing all those signals in the same place at the right time with the right context. Now, one last thing that I wanted to show you was that you can use all the other features that you have in Stackdriver, but particularly when you're trying to resolve incidents, very likely you want to explore things on demand. We mentioned before we have an integration with Prometheus. So all these Prometheus metrics have been already ingested into Stackdriver. So we're going to take a look at those with the Metrics Explorer. And with Metric Explorers, you have access to all of the objects, components on Kubernetes, all the metrics that are available. And as Shoukong is showing us right now, we have all the Prometheus metrics ingested already. So take a look at one of the JVM metrics that we have. So this is a Java application. So we have one of them. We can do the memory use bytes, have some interesting signals, Shoukong, that we can show. So we got auto-completion, gets you to the metrics that you need very fast, and then use bytes. OK, so we have a lot of signals in that sense. It may be hard to figure out exactly what's going on. But what we can do is we added a lot of dimensions to these Kubernetes objects, right? And so now you have labels and metadata that are coming from your environment or even from user-defined labels that you can use to filter and aggregate and group by to get you right very fast to where you need. And so let's filter now by service name as you're doing. And we knew before there was something with API gateway above, so let's filter by that one. And then you can further group by something else or aggregate to not just have a sum, but rather perhaps a mean or a 99th percentile or something of the sort. And then the last thing that you can do is you also do outlier mode. So we still have a lot of signals here, so you can look at the top n objects. And so we're now looking at the top 3, top 5 containers by JVM memory use bytes. All right? So that gives you just a whirlwind tour of the main things that you can do on the monitoring piece with the integration of metrics, logs, and so forth. So I'm going to switch with Shoukong so we can look at more of the troubleshooting scenario that started to occur right now.
Okay, so I'm going to give a demo about the troubleshooting scenario. So as a software engineer or operation engineer, one of the very common error case will happen and we will deal with in daily work is when your applications are receiving a large volume of traffic, your application may become less responsive or slow. And so this is what we have simulated a moment ago. If you recall, while JD is speaking, we generate traffic to both Kubernetes Engine cluster and on-prem cluster. And while you were watching the previous demo, I, as an on-call engineer, has been paged by an incident. So let's go to my Gmail account. And I see there already two incident report has been sent against to me. For example, like this incident has told me there are too many 500 has been returned from my services. And on the bottom of this incident report, there's a view incident link, which will redirect me to the Stackdriver incident overview page. So as you can see here, so my service is apparently returning a lot of 500 response. And this is concerning because this is how my customer are experiencing. And this is too many 500s than more than my SLO allows. So I want to I want to resolve this issue as soon as possible. Let's move to the custom dashboard I have previously built for my hybrid environments. So this is a custom dashboard I built before that to draw several charts about the very useful metrics to help me observe my hybrid environments. Let's quickly go through them. So on the first row, there are two charts about my HTTP request rate and error rate. This is sliced by the cluster. And on the second row, there are two JVM metrics because my Pack Clinic app is a Java application. So JVM metrics are very important for me, and this is corrected by Prometheus, and then it's stored in Stackdriver. I also have the CPU limit utilization and memory limit utilization and restart count, some classical system metrics I will take a look. And so, okay, so this is at a glance view of this dashboard. Let's see how we can use it. So from the first chart, we already see there's a reasonable amount, about 300 requests per second, goes to both my on-prem cluster and Kubernetes Engine cluster. This is working as intended because this is what my load balancer configs. But if we look at the second chart, which is my error rates, I can see that's about all of the 500 rates are coming from my on-prem cluster. So it's a very strong signal to tell me there's something wrong in my on-prem cluster. As a natural reaction, I may want to dive into my on-prem cluster and figure out what's wrong there. But our SRE best practice tell us we should contain and mitigate the issue first. So the ideal solution here is we drain the on-prem cluster and fail over its traffic to somewhere else. The first choice is our Kubernetes Engine cluster. So but before I do that, I want to ensure the additional safety. I want to make sure my Kubernetes Engine cluster can sustain the load if I double the size. So let's go to the Kubernetes Monitoring UI and take a look at the infrastructure view. If we expand the Kubernetes Engine cluster, we will see there are 6 nodes there. Some of the nodes are reasonably busy, but most of them are empty. So it gives me a confidence. I can fail over the traffic into this Kubernetes Engine cluster, and it's more than enough to sustain the load. So let's go ahead and do it. So from this terminal, what JD is doing is to scale down, manually drain the on-prem cluster by scaling the traffic down. And in the same time, we will go to Cloud Shell for Kubernetes Engine. And let's scale up the traffic. So this is how we do the manually failover from one cluster to another cluster. And then after the command finish, let's go back to our custom dashboard to see how the traffic goes. Yep, as you can see here from the chart, our on-prem cluster traffic has been dropping, and our 500 is also dropping. In a moment later, I mean about 2 minutes later, we will see the Kubernetes engine cluster traffic going up. So because we already see the 500 is dropping, this gives us a reasonable confidence this issue has been contained, since every minute counts in my firefighting scenario. So let's just jump directly into identifying the root cause. And then we will go back and then see whether my app has been back into normal state in 2 minutes. Let's go to Kubernetes Monitoring UI and go to Service tab, because this is where the service is returning 500. And open the on-prem cluster. As you can see there, the incident count column gives you a very clear signal where you should focus your attention to. This is like we need to go through an on-prem and default namespaces, and apparently API gateway is the problematic one. Let's expand it and then inspect the pods inside of it. So let's click on pod. We see there's a container returning too many 500s. And from first chart is a container restart. It doesn't have any restarts. It's a good signal. That means my container is running healthy. And we see the memory usage is reasonably high, but it's not out of whack. And we also see the CPU usage. It's also like about 80% use. Because we are receiving a lot of traffic, it is reasonable. Storage is flat, and network usage is high because we're receiving high amount of the traffic. So after looking all these system metrics, it doesn't seem to tell me my Kubernetes infrastructure is having any issue. It seems like, then what could be the issue? At this moment, it's the log will help us a lot. As you can see here, there's a log rate has been drawn here, and you can see there's an unreasonable amount of error logs has been written. And about 40% of your error log are errors, or of your logs are errors. And if we go down to the log snippet here, we can apparently see there's something has been thrown in here. It's probably go away because we have drained the cluster. Let's go to logs viewer. Go to login link on the bottom, and then it will redirect me to logs viewer with more focused view to get more details. This will filter down directly into the specific pod I was looking at, and then restrict to the time frame while my instance happens. This matters the most for me. As you can see here from the logs viewer, we already see a dozens of occurrence of the exception have been thrown from my code. As you can see, there's a runtime exception with the error message, unable to fetch details for owner one. And this is telling me something wrong in my code. And this is a stack trace, so I can scroll down and further and then see where this problematic line has been thrown. As you can see here, this is the API gateway controller, line 54. It's the one where the error has been thrown. Now, it gives me a very good confidence that this is probably this can help me understand something. Let's go to code. Okay, apparently it's not in this file. Let me do it.
Yeah, go for it.
Yep.
You know what we should do? We should show the debugger as well.
Yeah, sure. Okay. Okay, so this is the file where the API gateway is there. And then we remember the error message we say is unable to fetch details for owner one. So there's apparently 3 very problematic lines there. Somebody from my team has inserted this line to throw 500 after tossing a coin. This is like why my on-prem cluster is returning 500 for a portion of my traffic. So I have already identified the root cause. The next step for me is to fix the bug, redeploy the app to my on-prem cluster, and undrain my cluster. Then it will bring all my hybrid environment back to normal. So as you can see from this demo, Stackdriver Kubernetes Monitoring integrates both all the metrics, logs, metadata, and events that can give you the observability you need to monitor and troubleshoot your hybrid environments. We also want to give you one more demo about one other very important, very fancy thing here. So as you see, the scenario I show is a very simple troubleshooting because looking at the 3 lines of code, I know what happens. But in more complicated situation, it's very hard. Even you have the error message and stack trace, you won't be able to easily identify where the issue it is. Maybe because you are in a very big team, or maybe because you are developing a very complicated app, you don't know every line of the code. So as a software developer, I really wish I can do the debugging in the real world productions traffic. But we know it's almost close to impossible because in a local instance, you can debug with your IDE. You can hang on your application. You can step through all the code and see what's the environment variable value. Or on other ways, it's a more old school style. It's that you put the log lines, and then you rebuild your app, you run it, and then you see your log what's happening in your application. But we cannot do the second way in production as well because you don't want to, during your firefighting, you add some log line, deploy your app to production, and then waiting for the production traffic to hit it. It will take hours, and then it's deploying a problematic app during outages make you even more riskier. This is like almost impossible. But Stackdriver Debugger make it happen for you. So let's go to Stackdriver Debugger. So as you can see here, so because I deploy my code in GitHub, let's switch to my GitHub repo with my code. And if we scroll down, you will see the same code there. Within debugger, the thing I can do is I can insert a log point and a snapshot on my code. And it doesn't affect any of your production traffic at all. But in the meantime, it just assumes this line is already in your code and then export a log point or capture the snapshot and then writing both to your log to Stackdriver logging. And then you can see what is happening, what's the environment variable. It gives you very close to real debugging on your real world traffic. Let's give a demo here. So for example, in this line 54, that's the problematic line. Let's add a log point. Say, okay, so I lost coin toss. So that's why I'm about to throw a 500. And then I log it as an error log because it's easier for me to filter in future. And let's save it. Also, before I do the final return, let's add a line in line 60, let's add a snapshot. That can give you a sense before I returning this call, what my service environment looks like. Okay, so we have already set it up. We are waiting for traffic to hit because we already drained the on-prem cluster. Now we have to manually generate some traffic here. So let's just go to the owner details page. We need to go to owner details page. And then let's pick whatever one. And this is the 500. That's customer experiencing. Let's refresh, refresh, refresh. Keep refreshing because it's tossing a coin. So sometimes we'll get like, apparently it's a little bit unlucky. You see a lot of 500 here. So let's choose another one. Yeah, okay, we see a success case. Let's go back to debugging. As you can see here, so this is a call trace. That's a success case has been caught by my debugger. Let's open the owner's variable. This is the owner details. That's for the success case, where you can see this is the name of this owner, which we see successfully being returned, and all the environment variable this Java file contains. OK, we can also take a look at a log point. So for example, this is like the log has been written into your Stackdriver log storage. This is where you can combine with all other your information log. You can understand what's the flow, what's happening. It gives you close to your real world debugging scenario. And so this is the debugging. Another tool we can show here is also very useful, is trace. Using trace, it can give you a way to do the latency analysis. Like for example, the load we have generated, we have all been captured by Stackdriver tracing. This is a distributed tracing system. And we can see how it goes to how the traffic flows among multiple backends in my services. Let's pick a success case here. As you can see, this is hitting my on-prem cluster. And then first, it goes to the customer service. We can open the logs here to see what log has been written by each of the services. This is like log has been written in the same time. And it first go to customer service and then go to a visit service at the bottom, as you can see here. So this is collecting all the trace from all your distributed service call. We call it RPC call as well. And we can also take a look at the 500 scenario. If we switch here and filter by 500, there are some of the error logs we just hit. So from here, you can see if we open the show logs, this is where before it hits any backends, it just throw a 500. And then this is the error message and runtime exception has been captured. OK, so could we switch back to slides for 1 minute? So this is the end of this demo. We are going to
Right. So as Shoukong showed, the idea here again is you have many tools available, from monitoring to logging to debugger. We didn't show you error reporting today, but there's a few errors that you would see, and we categorize those errors directly for you, so it's easy to do exception analysis as well. And when you use all those tools together, you get very rich, comprehensive observability of your Kubernetes environment. Now, you can help with multiple things, of course. You can increase that observability for making sure that you get out-of-the-box metrics that your Kubernetes environment gives you. And so that we do that for you. We take that toil away from you to make it easy, very much in the way that Google does internally. And you certainly can supplement with third-party application metrics and your business-defined metrics, for which you can use Prometheus or anything else that you may want for instrumentation, hopefully using OpenSensor, so you can do it just once and then choose any other backend that you may be interested in. Make sure that these tools pay attention to resource requests and limits. And so on some of the tools that we have, on some places it would show you like no data available or no request or resource request or limit set. It is important, that's a good best practice, that you use that and set your resource requests and limits in your Kubernetes environment. And also you want to make sure that your information is available in a consistent way throughout. So take advantage of the Kubernetes labels. That's the way in which we organize information all together. So from your user-defined labels to anything else, so you can keep track of where your application is, no matter where it's running in the many different possible Kubernetes components that may be scheduled. So we're now at the end of the talk. Thank you very much for joining. We may have time for a couple of questions.